Okay, question 6 was all about the um, about this cylinder, about the volume and the surface area, and that put quite a few people off. But we can work this out just using circles and rectangles. So the first question wants an expression for h, which is the height, in terms of the radius. So how are we going to do that? We're going to look at what they've given us. They've told us what the surface area is. Um, and so we need to work out the surface area. We need to read the question carefully because it says it has an open top but a circular base. So the surface area is going to consist of the circular base to start with. Now that has radius r, and the area of a circle is pi r squared. Then we've got the bit around the outside. Now if you imagine that if we made a cut in it and stretched it out, that would be a rectangle. It would have height h, and the width would be the same as the circumference of a circle. Now the circumference of the circle is pi times the diameter, which is the same as 2 pi r, as the diameter is 2 times the radius. That means the surface area is pi r squared plus 2 pi r times h. Now they've told us that the surface area is equal to 48 pi, and now we're just going to need to rearrange that to get h. So 2 pi r times h is 48 pi minus pi r squared, and then all we need to do is divide by 2 pi r. And if you look at that, every term in that fraction has a pi in it, so we can cancel those out. So the height is 48 minus r squared over 2r. Right, now we've done that, we can move on to the next part. So we've got that. And now it asks us to show that the volume is this. So basically they're asking us to find the volume. Okay. Now, you might not remember the formula for volume, but let's think about it. It's going to be a circle, the area of the base, and so to get the volume, we're just going to need to times by the height. So, the volume is going to be the area of our circle, pi r squared, times by the height. Right, well you notice that the answer we're looking for doesn't have h in it, but that's okay, because in A part 1 we found a formula for h. So h is 48 minus r squared divided by 2r. So I'm just taking my answer from part A and substituting it in. And then we're just going to expand that. So we're going to multiply straight across the top there. So we're going to have 48 pi r squared minus pi r to the 4, all divided by 2r. So that's just multiplying fractions. Okay, we're nearly there. If you look at the answer, we now need to do some simplifying. So our volume is the same as 48 pi r squared divided by 2r minus pi r to the 4 divided by 2r. So that's just splitting the fraction up. And then we're going to cancel. So the first one, we've got 48 divided by 2 is 24. There's nothing to cancel the pi, but I can cancel one of the r's. On the second one, the pi is going to stay. One of the r's is going to cancel. That's pi r cubed, and that's divided by 2. And you can see that's the format they wanted it in. So we found an expression for h, we found an expression for v. Even if you couldn't do that, a good technique is they've given you in the question what v is, so you could do part b even if you couldn't do part a. So b part 1 is find dv by dr. So we're just going to differentiate the expression for volume. Now when we do this, we need to remember 24 is obviously a number, it's a constant. Pi is just a number and it's a constant. R is the thing we're differentiating. So a number times r differentiates to that number. Okay. R cubed, drop the power in front and take 1 off the number. Right. That's just normal differentiation. Now we're going to use that differentiation to find the stationary point, and then we're going to find out whether the stationary point is a maximum or the minimum. So to find stationary points, that's when dv by dr equals 0. So move up here. Okay, so we're going to take our dv by dr, 3 pi over 2 r squared equals 0. So we're going to rearrange this. So it'll be useful to have a positive r squared, so I'm going to move that to the other side. Notice we can divide both sides by pi. So I've got 24 equals 3r squared divided by 2. I could then multiply by 2 and then divide by 3. Right, so I've got 16 is r squared. So all I need to do is square root 16. Now, notice in the question it asks for the positive value. So normally when you square roots we'll do plus or minus 4, but it said the positive value, so we're just going to come to r equals 4. So that means we found the stationary point. Now we want to know if it's a maximum or minimum. And the way we do that is we're going to use the second derivative. So using our letters, that's d2v over dr squared. Now 24 pi is just a number. So when we differentiate, that's going to disappear. So 24 pi is going to go. Now that leaves me the 3 pi over 2r squared to differentiate. So that's going to become minus 3 pi over 2. The 2 is going to drop in front, so it's going to be times 2. And then it's going to become r. So that means if we simplify that, that's negative 3 pi r. Okay, we need to take our value for r and substitute that in to find out what type of point this is. So when r equals 4, d2v by dr squared equals negative 3 pi times 4, which is negative 12 pi. It's really important now to write our conclusion. So that means that d2v by dr squared is less than 0. We should state that when our conclusion. Therefore, it is a maximum value. If it's less than 0, it's a maximum. If it's greater than 0, it would be a minimum. You do need to be careful with your notation on this question and explain everything clearly in order to get full marks.